Alright, welcome back, ladies and gentlemen. We're on to section 12.3, day 1, the tangent line problem. Sounds kind of mysterious, but here we go. We're going to find the slope of a curve at any point using limits. Alright, you can see the assignment over here on the right hand side, but here we go. Alright, the slope of a line. Okay, we're going to use this today, so I'm going to insult your intelligence a little bit here and do this problem. Alright, find the slope of the line passing through this. Okay, well, if I'm talking about a line, the slope formula is real easy. Slope equals y minus y, and again, the order doesn't really matter. I'll just stick with the y2 minus y1 sort of thing. So 4 minus negative 2, and then negative 7 minus 3, and then just kind of crunch the numbers. I get 6 on top of a negative 10, and after a little bit of reducing, I get negative 3/5. Yawn. Algebra 1 students can do that, no problem. Alright, but we're going to kind of use that and use it in ways that Algebra 1 students wouldn't have a clue what was going on. And here it comes. Alright, so first question I have for you is, what's the slope of the function f of x equals 4x plus 2? Hopefully that one is super obvious, because of course y equals mx plus b is basically what you're looking at right there, so the slope is 4. And it's a line, so again, if I just draw a super quick sketch of this thing, 4x plus 2 would look vaguely like that. And that's a slope is sort of a constant thing. Alright, but what's the slope of the function f of x equals this guy? Okay, well, knowing what we know about polynomial functions, if I have a negative lead coefficient and an odd power as my lead term, that means I kind of have my barrel of monkeys looking graph, but it's flipped upside down, so it's actually high left and low right. So without any more specifics, I know it's doing something kind of like this. Okay, what's the slope of that thing? Well, over on this end of the graph, the slope is going to be a fairly large negative number. Coming over here, it's going to flatten out for a second and be kind of close to 0, and then it's going to turn positive up here, and then again it's going to kind of flatten out a little bit, and then go off toward negative infinity as far as the slope. So the slope here is constantly changing. And so basically it's impossible to give an exact answer for a slope of this entire polynomial function, because, if you look at one point in the graph, it's doing something, and you look at another point, it's doing something else. Alright, so we need a way to handle this. Alrighty, so a good approximation can be achieved if we do this. Pick 2 points on a curve and calculate the slope of the line that passes through those points, which is the secant line. Okay, now you might remember the term secant from circles, which would be a line that passes through the circle. Secant line relative to a curve is basically the same thing. So if I put that line right there, you can see that my line and the curve are pretty close together. Not dead on, but they're pretty close. So again, this is why it's an approximation to that part of the curve. Okay, so here it is. So just picking those 2 points, drawing a line between it, and okay, let's go. So 17 minus negative 3 over 2 minus 0. With a little bit of work here, I get a 20 over a 2, so my slope ends up being 10, at least for that line. And again, the curve is going to be pretty close to that, at least between these 2 points. Okay, obviously in different parts of this curve, it's going to be negative over here on the left, it's going to be negative over here on the right, and again, kind of positive in the middle. Therefore, it must be kind of 0 on kind of the top and bottom, but we'll talk more about that later. But again, it's a good approximation, but maybe we can do better. Alright, so obviously, as I just said, we like a way to get the slope of an exact point, doing better. Alright, so finding the slope of a secant can get a good approximation, but we want to get the slope of a particular x value. Okay, so we want the slope exactly right here. And the slope will match the slope of a tangent line, because we can find the slope of a line, although the curve is very tough. But if I go for a tangent, like if I take this line here that I purposely drawn to look like a tangent, so alright, that guy looks pretty well tangent to that graph. It's just going to hit at one point. That's pretty good for the 0, negative 3 point, but obviously the 217, okay, our tangent for that guy is going to look a little more like that. So definitely a different slope of the two. They're both positive, but definitely this first one's got a much steeper slope than the other one. Alright, so there's got to be a way that we can figure out how to do that. So let's talk about that. Alright, so now in order to find the slope of a tangent, we're going to need to find the slope between 2 generic points. We're going to use these 2 points whose x values are h units apart. Alright, so basically here's my diagram of my parabola-esque looking thing. Not exactly the function we're working with, but it will serve our needs here. Alright, so my first point is going to be my red point. So I've got x, comma, whatever this is, and I'll call that f of x, remembering that f of x is simply a fancy way to say y. Alright, so my first point is x, comma, whatever I got by plugging in x. Alright. Then from there, my green point, notice where I just went h units further on the x-axis, and then calculated another point. And by plugging in x plus h, I got the y value from x plus h. Alright, so basically there's my 2 points. Alright, so, well, those are 2 points. I can imagine a secant line going between these two, and I'll just kind of draw it in by hand here. Alright, so there's my secant line. Alright, so the slope of that guy, alright, is y2 minus y1, so f of x plus h minus y1 is f of x. That might start looking familiar. And then that's going to be over x plus h minus my x. And okay, I can do a little bit of cleanup here. Alright, nothing on top. F of x plus h, because remember I can't distribute the f or anything like that. Alright, f of x divided by, okay, x and the minus x cancel each other out and just leave me the h. Alright, so basically the slope is that thing. Alright, so here it comes. Okay, that slope is still the secant of a line, so that little formula we just came up with. But if you imagine the value of h to be infinitesimally small, effectively 0, so basically instead of h being way far away, what if h was this microscopic distance here? And this green point that's right here kind of tracked down and to be just unbelievably close to that guy right there. In fact, we want it to be so small that it's effectively 0. Alright. What that does for us is it still is letting us calculate the slope using 2 points. It's just that we want those 2 points to be really super close together. So basically the slope at any point on a curve for any x value is the limit as that h value gets really small, so approaches 0, of that formula we just came up with, f of x plus h minus f of x all over h. And that probably looks very familiar to you. We just never called it what it really is up until now. It's really a slope formula. Dun, dun, dun. Alright, now that we've got a method for finding the slope of a function that's curvy, let's put that to work and see how it looks in action. Okay, now one little thing we need is we must have a point or at least an x value specified, because, kind of like what we said before, is if I think of this curve, h of x equals root x minus 4, and kind of it's like this upside down Nike swoosh sort of thing. Okay, notice at the very beginning of this curve, we have a very steep part of here, so our slope is going to be a very large number. But as we continue on the curve off to the right, the slope gets kind of smaller and smaller as this thing flattens out. So again, it's hard to say a specific number, but if I specify the 0.51 here, okay, that means I can kind of imagine the 0.51, and I can imagine a tangent to there and say, okay, cool, now I got to figure out the slope of that, because that's the slope of this curve at that particular moment, and I can get a number for that. Right, so here's what it looks like in action. Okay, now again, basically my slope is the limit as h approaches 0 of that good old f of x plus h minus f of x all over h. Never mind L mark. Alright, so start plugging in and see what we can do with it. Alright, so limit as h approaches 0 f of x plus h, so again I just plug in x plus h there, so I get root x plus h minus 4 minus the original f of x, so minus x minus 4, and this is going to be all over our h. Okay, now again, of course, if I plug in as h is 0, I get something undefined, so I have to do something to fix this mess, and since I'm looking at a whole bunch of roots, I'm going to try to rationalize my numerator here and see if that sorts things out. So multiply by x plus h minus 4 plus root x minus 4. Again, same exact thing, except instead of a minus, we're going to use a plus, so it is a conjugate of sorts. Kind of a messy one, but there it is. Of course, we have to do the same thing top and bottom. Okay. Alright, starting to sort this mess out. Again, we have a conjufoil on top, so my numerator becomes x plus h minus 4, and then it's going to be, now careful with this, now it's going to be minus root x minus 4 quantity squared, so it's really minus x minus 4, so distributing the minus sign gives me minus x plus 4. Okay, that plus sign right there is going to be a problem if you're not paying attention to your signs. Alright, again, I'm still doing the limit as h approaches 0 of that guy over the h, and I actually also have the big nasty root sort of thing here, x plus h minus 4 plus x minus 4 down in my denominator. Sorry, that's a little bit messy. Alright, and for lack of space purposes, I'm going to continue this in the next slide. Alright, so there's where we left off. So at this point, now I can look at my numerator and say, hey, wait a minute, a whole lot of stuff cancels. The minus x and the positive x take each other out, and this positive 4 and the minus 4 take each other out. So again, I'm left with just an h on top, which will nicely cancel with that h on the bottom. So really what that gives me is the limit as h approaches 0 of 1 over this nasty square root looking thing. X plus h minus 4 plus root x minus 4. Okay, sorry, that guy should probably be a little bit longer. Hopefully that didn't mess you up. Okay, so at this point, now if I plug in my 0, nothing bad happens as far as an undefined value or anything like that. So I can take this 0, plug it in right there, and what that gives me is 1 over x minus 4 plus x minus 4, so I've got 2 root x minus 4s. Alright, and again, remember what this basically is my slope. So right now I have slope equals 1 over 2 root x minus 4. And now remember, I wanted my slope at the point 5, 1. Okay, so basically all I need to do is plug in the 5. Honestly, the 1 is kind of irrelevant. I can plug in the 5, which is the x-coordinate, into this. So now my slope at that particular point on the curve is 2 root 5 minus 4 under the 1. So that equals 2 root 1, and please don't leave that as if it's not simplified completely, because it's not. Alright, square root of 1 is of course 1, so really that's just simply 1/2. So at that point on the curve, my slope is actually just a nice clean 1/2. So that's how that goes into play, and you can figure out the slope at any point using that little formula sort of thing. Alright, now with this newfound superpower, we can take this a little bit further and find the equation of the tangent line. So not only can we find the slope, of course, we can find the slope, we can find an equation, as long as we're working with a point. So if I've got this function and I want negative 1, 3 as my point of interest, alright, I want to find the slope there. So again, if I draw a plot that point and draw a tangent, well, it's going to look something like that. Alright, so I want the equation of that tangent line. So again, I can kind of ballpark it right now and eyeball it and take a guess, but of course, guessing is not quite going to be good enough for our purposes. We want to be able to be exact about this. So, let's go do this thing for real. Alright, so, again, I want to do the limit that we just did. So again, in case you need to see it, my slope is really my limit as h approaches 0 of f of x plus h. That's sloppy, I apologize. F of x, and it's going to be all over h. Okay, so now plugging in what we have based on the equation we have. Alright, we've got the limit as h approaches 0, f of x plus h. Well, that's going to be x plus h quantity cubed minus 4 times x plus h. Okay, so that's just the first half of this thing. So now we got a minus the original, minus f of x. So that's x to the third minus 4x. And that's all living on top of that h. Alright. Now I'm sure you don't want to watch me foil this thing a whole bunch, so I won't go through that painful process. At least on here, if you want to see it in class, I'll be happy to explain. But if I FOIL out x plus h quantity cubed, I'll eventually get x to the third plus 3x squared h plus 3xh squared plus h to the third, and then distributing the 4 gives me a minus 4x minus 4h. And then I've got the negative sign in front of that, so I got negative x to the third plus 4x. That's a big nasty mess, but that's what we have. This is all over h. Alright, so again, there's going to be a lot of stuff that's going to cancel here. For instance, the x to the third and the x to the third will cancel, and then the 4x and the 4x will cancel, so well, maybe that's not your definition of a lot, but what I'm also getting at is that I'm eventually trying to cancel out the h, and if you look at everybody who's left, they all have an h in them. So, for the sake of clarity though, I'm going to rewrite this whole thing. 3x squared h plus 3xh squared plus h to the third minus 4h, and this is all on top of an h. So my next step is going to be to cancel an h, but since I'm running a room, we'll do that in the next slide. Alright, so picking up here is the step we were just on, and as I said, now that I've got every term with an h in it, I can basically cancel out the h in the bottom with at least one power of h for all these guys, and what that leaves me with is the limit as h approaches 0 of, I'll put a parenthesis down here to hold it all together, 3x squared plus 3xh plus h squared minus 4. Alright, and again, now that I've gotten rid of any possibility of a undefined value by getting rid of my denominator, I can now plug the h into every place that I see an h. And again, in this case, since it's 0, it's really, really nice, and those things got to disappear completely. And so basically the limit as h approaches 0 is 3x squared minus 4, which again, remember, is the slope of this guy. Alright. So since we want our point to be at negative 1, 3, alright, again, that's the x value that I want, so I plug it in for the x value here. And so the slope at negative 1, 3 is going to be 3 times negative 1 squared minus 4, which is 3 minus 4, or simply negative 1. Alright, so there's my slope, and hey, look at this, I've got a point, and since I have those, I can use my good old point-slope form of an equation, so kind of transition right here. I'm going to use my good old y minus y1 equals mx minus x1. Okay, you may have a different preferred method of getting the equation once you have this information, but this is what I'm going to do right now. So y minus my y, which is 3, equals the m that we just found, and x minus the x1, which is a negative 1. Okay, hopefully you look at that and just think plus 1, but whatever the case. All I have to do now is distribute my negative 1, so that gives me a negative x. Remember, that's a plus, so it's basically that. Negative 1 times the 1 gives me a negative 1. Adding 3 to both sides gives me a final equation of y equals negative x plus 2. Alright, and again, if you refer back to what the graph looked like, okay, negative x plus 2 looks pretty reasonable. Again, remembering that the x-axis here versus the y-axis are not using the exact same scale. So I think, though, the 2 looks pretty darn reasonable there, so I feel pretty good about our answer, negative x plus 2. Alright, so there it all is. Of course, as usual, if you have any questions, be sure to ask me in class. See you then.